Welcome everyone to the webinar. My name is Anand Akela, and I'm the Chief Marketing Officer at Acalvio Technologies. Acalvio is a leader in cyber deception technologies, and it helps enterprises actively defend against advanced security threats. We have Chris Ray, who's the GigaOM analyst. He's been doing research on deception technology and has been a cybersecurity expert for many years, joining and talking about the GigaOM Radar that he published last month. And we'll have Suril Desai, who's our VP of Engineering, join us to add some talk about some use cases. Before we get started and I hand over to the gentleman, I wanted to point you to the Q&A button at the bottom of your screen. Please submit your questions there. Please keep submitting the question as they come, but we'll take the questions at the end of the session. We have a really great agenda for you. Chris will start with talking about the evolving threat landscape, the role of deception technology based on his research, and Suril will chime in and talk about some of our perspective. Then Chris and GigaOM had published key criteria for evaluating deception technology solutions, which is a good research paper for you guys to look at, and he will talk about that. And then he will talk about the GigaOM Radar, the process behind that, and how Acalvio is positioned there. And then finally, Suril will come in and talk about some use cases of deception. With that, let me hand it over to Chris Ray. Take it away, gentlemen.
Thank you, Anand. As you mentioned, I think many of the viewers, many of the people watching right now, those who will see this in the future, they recognize that the threat landscape is changing, and not for the better. They know that their job is getting more difficult. Attacks are getting harder to detect. When attacks occur, they are more severe. There's probably some other things in there that I could talk about. As pointed out on that slide there, identity is a focal point for the evolving threat landscape. 75% of attacks are malware free. What does that mean? It means your legacy approach to detecting bad things in your enterprise or organization's environment, they are not going to be as effective as they were previously. You need a new approach to detect these things earlier on. So as we see here, attackers are continuing to evolve their tactics. 2,000 plus vulnerabilities disclosed each month in 2023. 2023 had all-time high for breach count. Ransomware as a service, it's growing. The core of most cyber attacks is focusing on identity. Identity also just happens to be one of the most difficult to detect and secure on the vulnerability or the risk front. Suril, did you have anything you wanted to add there?
Yes, thanks, Chris. Good observations. And yes, so the threat landscape is significantly evolving. Some of the other interesting things is the speed of the offense. And so, for example, the adversary breakout time is now down to 62 minutes from an average of 84 minutes earlier. And what does that mean for the defender? So fundamentally, it means that the adversary gets to an initial beachhead, and from the beachhead, they will propagate. Now, if that time is dropping rapidly, then the defense clearly needs a way to detect early and detect quickly, because otherwise the adversary, once propagating, is very difficult to stop. So that's another example that is of interest and importance.
Yeah, and as you point out here, we have different avenues that these attacks are coming in. If we look back 10, 15 years ago, generally the security organizations, the security teams within organizations, they're focused on defending their endpoints. They're focused on defending, maybe they're in a cloud, but they're probably focused on defending the perimeter of their on-premises environment. Fast forward to today. Now we're focused on protecting our identity. We're focused on protecting our supply chain, our code repos, our cloud workloads. The way we've defended those items previously, we were really just kind of lifted and shifted detection principles from the historical endpoint centric to the now identity, cloud workload, and cloud infrastructure, and it wasn't a great fit. There needs to be an improvement or a complete change in the detection methods. That's really what we're here to talk about today is how deception solves for some of that pain.
So with that, let's get to our first poll question. I'll read that. You have 30 seconds to respond. Your poll will show up on your screen. So what is the most important cyber threat that you're worried about? Is it ransomware, insider threat, identity compromise, data exfiltration, or cyber chain attack? We're starting to see 20 of you have responded. We'll give another 10 seconds. Another couple of seconds, and then I'll stop and show it to you, and then we'll get to the next part of. Okay, so you could see the results there really quick. It looks like ransomware and identity compromise is at top of your list. I'm going to stop sharing the results and hand it back to Chris and Cyril.
Thanks, Anand. That's interesting that ransomware is still at the top. I mean, it's been at the top of our minds for how long now? Since 2016, maybe 15. It doesn't seem like it's going away, and identity's catching up. Maybe it'll surpass it, unfortunately, here in the near future. So, as we've been talking about, the lift and shift of taking your traditional detection methods from the past and moving it to your new attack surface, your code repos, your supply chain, your identities that exist, hopefully in a centrally managed IAM solution, but very likely you'll have some identities that exist in many different technologies that you can't centrally manage. All of those things complicate the job of the defender. So when you start looking at what are your available options, you quickly realize that the traditional detection methods, your AV, your IDS, even some of your cloud infrastructure services, they are woefully under-skilled, under-tooled to be able to detect these new threats. As Matt Graber's pointed out, I feel like this is a famous quote at this point. A sufficiently advanced threat actor is going to be indistinguishable from a capable, competent systems engineer. What does that mean for somebody who is tasked with defending an environment? It means your adversary now is blending in with the herd, living off the land, not using malware, using PowerShell if it's a Windows environment or Azure, using Python or Go, and moving around and creating a havoc and building infrastructure internally that, it just looks like, hey, that's our infrastructure team doing their regular work. How do you detect against something like that? This is really starting, kind of set the stage and talk a little bit more about, well, maybe you need something that can deceive or trick. You can bait them in, you can lure them in. How do you do that? And, we'll get to it eventually, but that's really the core of deception. Cyril, did you have anything to add?
Yeah, a couple of examples. Thanks, Chris. And on ransomware, so for example, if you take the Alfie or Black Cat ransomware that compromised United Health about a couple of months back, if you look at the analysis of this ransomware, there's lots of variants of the ransomware that are being released by these threat actors. And so, for example, in this particular offensive campaign, a new variant called the Sphinx variant of Alfie was released, which is the one that actually did that compromise. And that entire ransomware has been written in the Rust programming language, okay? And there is a reason why the threat actor decided to use Rust. It's because traditional forms of signature-based tooling are all having signatures looking for malware written in C and C++. because that's what traditional malware was built off. So now the threat actor said, okay, I have many other choices. I can use Rust, I can use Golang, and if I write malware in those languages, there is no signature for those things available. And so we can trivially evade current forms of detection by simply choosing a different programming language. And that's exactly what IoT has done. And so there are many such choices for the threat actor that they have. Curb roasting is another example of an identity compromise where everything offensive about the identity threat is being done outside the enterprise perimeter. And so if you look at any detection layers, whether it be logging on the domain controller or whether it be inspection of the network traffic, you will not be able to detect a threat like that, a stealthy identity threat, because everything malicious is actually done in the attacker's CNC. And in the enterprise environment, everything looks legit. So that's a couple of examples of how these threats have become very stealthy.
Yeah, if we can hold here for a second, I think you touched on it. Kerberos, the protocol, that's a great example of how it's not a modern protocol per se, but it's being used more broadly. It's adopted more heavily. It's also, if you're using it in anything other than Microsoft Active Directory, the way they want you to use it, it's also a very complex protocol to implement successfully, manage, and observe. Well, guess what? Kerberos is also the core of your identity management in most organizations. So now you have a very high reward item, user identities, system admin identities, running or supported by, enabled by Kerberos, a protocol that's very complex and difficult to understand. That's a recipe for disaster for traditional detection methods. You have this very complex technology that is not very well understood. How are you going to protect it? All right, thank you. So, now let's get into what I've been touching on for a little bit. How does deception change the game for defense? Almost all of the detection methods I've talked about so far, the IDS, the AV, the EDR, the XDR, your CloudTrail, CloudWatch, and AWS, the similar services available in Azure and Google, they are all watching, monitoring, recording, and tracking. That's great, but you need a threat actor. You need an adversary to take an action on something and hope that you have logging and events and observability on that action. That's great. But what if they're waiting? What if they're observing? What if they're collecting information? They're not going to create events that are going to be detected by EDR, by CloudTrail. They're just sitting there for weeks, maybe months, looking for the opportunity. The opportunity that they're looking for, however, may be presented to them by deception technology. Like I touched on before, leaving bait, an intentionally, the classic example is an intentionally vulnerable system. We call it a honeypot. I think that's what everyone knows it as. That's a really generic example. I think everyone knows that example. What everyone may not think of, however, is in a cloud environment. Maybe you turn a bucket storage, S3, you turn it loose and you put some, what looks like very interesting and attractive information in there. It could be credentials, could be API keys. It could be client PII. You put it in there and anybody who works in the organization, they're not going to be interested in that. Either they know it's deception or it doesn't have anything to do with their work. It looks sensitive. They don't even want to open that rat's nest. They're just going to leave it alone. However, to somebody who's inside of a network, and they stumble across a bucket of storage of sensitive information, bingo, that's what they're there. That's what they've been waiting for. So what deception gives you is early defense, high fidelity detections for behaviors that are otherwise very difficult to observe. Did you have anything you wanted to add, Cyril?
No, thanks, Chris. That was a great summary.
So moving into our stance on deception technology. There's a lot of text on the screen here, but I think the main takeaway for an executive summary here is the bolded part. For organizations seeking the earliest possible detection, deception technology is a very appealing solution. And then moving down the business imperative, why should I adopt this? Why should I advocate for purchasing this? Why should I advocate for devoting resources from already overworked security teams, infrastructure teams, application, whatever it may be? Why should I be requesting that I need some of their time bucketed to help deploy this? Well, as you can see, incorporating deception technology should no longer be viewed as an optional component. This is moving the detection component earlier in the attack lifecycle. How valuable does that become to detect before something bad happens? It's very valuable. So this is a great slide. Defense in depth. I think everyone who's worked in security long enough, they know you need multiple layers of protection. However, what does each layer look like? Can you have multiple layers that are very similar to each other and achieve optimal outcomes? No. Can you have multiple layers that are protecting the same asset, just at different, host level, network level, identity, the cloud perception? Yeah, that's getting better, but we're still in the ballpark. We're still talking about IDS, CloudTrail, event monitoring, observability, AV, XDR, EDR. We're still talking about those. So really, defense in depth needs something to draw the attacker out of the woodwork and entice them into taking an action that they may not otherwise do. And that's really where deception shines. You couple it with your traditional detection technologies, and you add deception on top of that. Now you've got a much more comprehensive defense in depth approach.
And so quick input on that is that, traditional layers are good at detecting known attacks with known TTPs. And so, for example, if you set a signature or a rule where you say, I know that the offense does the following things, I'm looking for a particular pattern, and if the threat matches the pattern, then I classify that as malicious, right? So that's typically one of the areas where traditional layers excel. But there are, as we saw earlier in the discussion, the adversaries are evolving their threat actor techniques, right? So there are lots of new novel ways of doing offensive security, which are unknown threats that the traditional layers cannot detect. And so deception is based on a completely different premise where you're not looking at an attacker TTP. Instead, you're trying to say, I'm going to give you an opportunity for the threat to go and after what is something of value, as Chris mentioned earlier in the discussion. So effectively, you set a trap for the adversary. The trap represents something of value, and then you observe for the activity against the trap. The adversary will get there. Even if they come after with a new technique, you will get a detection. So you combine the views of multiple detection layers, and that's how you can actually get comprehensive cybersecurity and defense in depth. So that's what is our understanding in this area.
Yeah, you really put into words something I've had a hard time myself verbalizing, but deception is really TTP agnostic. Tactics, techniques, procedure. It doesn't care. It's really just focused on the outcome. So moving into opening the hood, peeling it back, looking at what is deception. This slide here. I think everyone's familiar with a honeypot. That's a intentionally vulnerable system somewhere in the enterprise, somewhere in the organization that is so vulnerable that it's going to entice an attacker into interacting with it. That is the cuckoo's egg, 1987 version of deception technology. And actually that ran through the 90s, into the 2000s, into the early 2010s. There really wasn't a lot of innovation in deception. I think because of that, deception technology for a very long time was viewed as sort of a one-trick pony. It is that vulnerable system, but it's nothing more than that. However, in the last 10 to 15 years, there has been a rapid evolution of what deception can be. And as you guys have laid out here, that includes now technologies like a decoy, a bait, or a lure, depending on where you go. Honey tokens. These are all objects that are intentionally deceptive in nature, but have different use cases, as you lay out here. A decoy, it's a new target for an attacker. a bait. This is something that, much like fishing, you use the right bait for the right kind of fish that you're going for, and you can pull them out and you can get some action going. So baits, these could be things like, I don't want to conflate honey tokens with baits, but they're very similar. This could be Kerberos credentials. This could be API keys that when used, they trigger an alert. This could be a document. This could be a PDF. This could be anything. That's really the intention of a bait, is going and, as we talked about previously in the last slide, looking at MITRE ATT&CK TTPs, tactics, techniques, procedures. You can then go and say, okay, I know that during the reconnaissance or during the foothold stages of an attack, they're very likely, an adversary is very likely to try and do these three things. Well, I'm going to design baits that would be involved in those three things because I want to detect them earlier in the attack lifecycle. Honey tokens, these are great. They really take deception from that legacy honey pot, and they now use it in a very more generic, applicable way. A good honey token can be applied on-premise. It can be applied in a IaaS platform, PaaS, even SaaS. Drop some API credentials in a Google Doc and leave them in your drive. No one's going to use those except for a bad guy that's searching Google Drive looking for something bad. Did you have anything you wanted to add here, Saurabh?
Well, that's good, Chris. Thanks.
All right, let's get into the key criteria. I'll explain a little bit of what this means. So as we're researching a topic, we establish table stakes. These are the features that a technology must have in order to be considered a basic participant in a space. We don't have those here because they're not all that interesting. However, key features are where things get more interesting. Key features are the capabilities or the features of the technology that not all vendors have, or if they do have all of these features, they execute on them at varying levels. And so that's what you see here. The emerging features, these are features that are on the bleeding edge, very new. Not all vendors have them. If they do have them, they're just released, and they may not be executing on them to their fullest depth. So generally, the life cycle of a feature is it comes out as an emerging feature. It's proven to work. It gets broader vendor adoption rolled out across the industry, and it turns into a key feature. And then eventually, a couple of years goes by, that key feature eventually evolves into a table stake, as in you need to have this feature in order to be considered this kind of technology. So key features for the deception technology space, deployment management is a very big one. It's great that you have honeypots and honey tokens and baits and lures and decoys, but you do not want to be manually managing the deployment and the updates of those objects. Cross-platform support, we're talking about on-premises, hybrid networks, cloud, IaaS, platform as a service, SaaS, behavioral analysis. This is really talking about refining the signal noise and tuning it in to only the events that are truly attacker behaviors. Because some deception technology can be noisy, you need another feature, another layer on there to tune out the noise. In some cases, that's behavioral analysis. To be able to customize the level of engagement of a honeypot is very powerful. An example of this would be just leaving a vulnerable version of SSH open. Okay, that's good. But now what if you want to mimic an Active Directory domain controller? Maybe you want to mimic a Samba SMB server. Well, maybe you want to mimic a specific version, or maybe you have to go even further. You have a bespoke application that you need to be able to mimic. You don't want your real application presented as vulnerable, but you want to take your bespoke application and present it as vulnerable. Those are all different flavors of customizing the engagement level. Multi-layer deception, much like cross-platform support, not to confuse these. Cross-platforms focusing on premises, hybrid, your cloud scenarios. Multi-layer is now looking at the tech stack, your layer 2 through layer 7 networking, your endpoints, your cloud services. So AWS S3, AWS EC2, Azure VMs, that sort of approach to defining the deployment. And then finally, OT and IoT specific decoys. OT, operational technology, it gets a bad rap that it earned for quite a while, but not anymore, as being very difficult to secure from a cybersecurity perspective. It's not IT, it's not information technology, it's not easy to manage, it's not well understood. This is OT. Well, it turns out deception is a fantastic tool to be deployed into OT environments because it's not noisy, it doesn't disrupt the environment, it's very attractive to attackers that are able to look into the OT environment. And then moving into the emerging features, we have adversarial AI countermeasures. You may not know, or the crowd may not know, the viewers right now, AI, LLMs mostly, but also some machine learning algorithms, they are being employed by the adversaries. So now we need to consider that as a tactic that we need to detect and just basically make it more expensive, because that's how all these attacks work. You increase friction, you make it more expensive, they will move on to the next target. Deception is very good at doing that. And then finally, cloud native deception. What we're talking about here is, are you able to, as a deception technology platform, connect to cloud services, Azure, Google, AWS, and are you able to deploy deceptive AWS native services? And that's really what the focus is there. Moving on to business criteria. These are, very simply put, how do you evaluate a solution? So we've set the stage with the key features, with the emerging features. That's great. You understand the capabilities. How do I now go into the market landscape and evaluate which one makes the most sense for me? We've defined these 4 business criteria: the cost, the scalability, the flexibility of the solution, and how easy is it to use. We can move on, Sabrina.
All right, it's time for our next polling question. I'm going to launch it on your screens now and leave it open for 45 seconds or so. So, which is the most important business criteria for a deception platform for your organization? Scalability, flexibility, ease of use, or cost?
This will be interesting. I have my own pick, but I'm going to see if it aligns with reality.
Yeah, I see people entering. I'll leave it open for another 10-15 seconds. Please fill. I already see a couple of questions in there. Please use this time to submit your questions as they come, and we'll take them in another 10 to 12 minutes at the end of the session. Okay, I'm going to end the poll and share the results on your screen. So,
all right.
Chris, do you want to comment on the results?
Yeah, I was just going to say, ease of use is a very big one for me. If I had to weight the 4 business criteria here, I would score ease of use higher than the others, because ultimately deception is only effective if it's frequently used and deployed. The best way to make sure it's frequently used and deployed is to make it easy to use. I will pay more for something that is less flexible, less scalable, as long as it's easy to use.
Sounds good. I'm going to stop sharing and hand it back to you guys.
All right, so in the report, I've also defined, there's really 3 primary market segments that care about this. Not to say if you don't fall neatly into one of these, deception technology doesn't benefit you in some way, but these are the big 3 personas. You have the SMBs, which are going to value a good balance of ease of use and cost. You have the large enterprise, which is going to be more concerned about flexibility and scalability. And then you have the public sector, which will focus a lot on can it scale? Is it approved for use and what I need to use it for? And then last, for a lot of public sector, is it easy to use? So with your solution with Shadowplex here, one of the things that really stood out to me during my research is the Shadowplex technology. The Shadowplex platform is feature rich and very advanced, when compared to the peers in this space. Feature rich meaning those key features that I laid out, including the emerging features, the Shadowplex technology executes on them and does them all very well. Some of them better than any other technology in the space. The other thing is the scalability of the solution and the ease of use, which I mentioned. I weight very heavily in my own mind when I'm shopping for cybersecurity solutions. The ease of use, the scalability are very, very good because of the deployment methods. Cyril, did you want to sort of fill in the deployment method here at a very high level? We don't need to dive into it. I think it's unique and should be discussed.
Sure, absolutely. Thanks, Chris. So we have lots of innovation in the ease of deployment. So one of the important ones is it's completely agentless. So we don't put any agents on production endpoints. So that way we don't increase any deployment friction. So that's one aspect. The second aspect is we use AI algorithms to automate the recommendation of deceptions. So that way the administrator does not need to manually specify the deception characteristics. The third option is the third capability is we have something called deception playbooks, which effectively allows you to set up a design or a template of deception and deploy that at scale across a wide and hybrid enterprise environment. So these are the three key differentiations in this area.
Yeah, if we can just pause here for a second, roll back to the second part of that. You use AI to inform the system administrator of what deception technology or technique or procedure is the most appropriate for the situation. That's really important because we have to remember, it's not always going to be a cybersecurity engineer, an architect, a SecOps team operating the security tooling. It can be, and depending on the organization, public sector, SMB, less likely in large enterprise, but it could still happen. It can be somebody that doesn't understand the threat actors that they're going up against. They don't know the threat landscape. So then to have a built-in expert system recommend, hey, based on what the past has presented, based on the industry you're in, based on the technology we're looking at here, it's probably best if you go this route with your deception strategy. That's very, very powerful. As you can see here, the key features, as I mentioned, you scored very well. This is on a scale of 0 to 5. So 4 stars, 5 stars. This is, I would say in my head, I always think 3 is average. And average isn't bad. In some spaces, keeping pace in a very high evolution, very high feature space, keeping pace with your peers, that's a 3. That's very good. As you can see here, you guys scored 4s and 5s across the board. That's no easy feat in a space that's rapidly evolving like deception technology is. All right, so this is the fun part. For those of you who haven't seen a GigaOM Radar before, let's start with this blank one, and I'll introduce the abstract concept so that when we show you the populated one in the next slide, you'll have an understanding of what it all means. So top to bottom, we have maturity versus innovation. Left to right, we have feature play versus platform play. And then you'll notice there's 3 rings. We have entrant, we have challenger, and we have leader. With the bullseye in the middle, generally meaning that's where you want to be closer to the middle of the report. And then finally, we have forward mover, fast mover, and outperformer as designations for each vendor. All this means is a forward mover is innovating at a slower rate than a fast mover, and an outperformer is innovating at a higher rate than a fast mover. Generally, fast movers are going to be the most common designation in a space because fast mover is the average of all the peers when we look at them. Those that are releasing features at a slower rate are probably going to be a forward mover. Those who are innovating and releasing more features, which may or may not always be a good thing, those can be outperformers. So when we're talking about what constitutes left to right, feature versus platform, we're quantifying the number of use cases that the technology applies to, and then looking at the number of unique use cases that technology solves for. Obviously, weighting the unique use cases more heavily. So for a platform to exist, it needs to solve for many, many use cases. It's going to shift to the right. If a technology is focusing very deeply on just a handful of use cases, that's going to shift it to the left. And then finally, the maturity versus innovation. What does that mean? A mature vendor values stability over a very rapid release schedule. Whereas an innovative solution, they're going to test the waters. They're going to release features that may be dubious in value, but they're going to let their customers tell them. And then, of course, as is the case, very rarely is anything 100% purely this or that. So you'll see vendors landing somewhere top to bottom, somewhere left to right, as they are all a blend of either feature and platform or a blend of mature innovators. Go ahead, Cyril, if you want to move on to the next. So then, as you can see here, Calvio lands in the leader ring. They are a mature platform solution, meaning they solve for many use cases in the deception technology space. And they are also a mature solution, which again points to their approach to releasing features and updates in a maybe a slower manner, but in a stable manner where they're not going to be rapidly changing how the solution works, looks, or feels.
So we'll discuss a set of use cases of deception now. And so the idea is that deception in itself has important value in the ability to provide early and precise threat detection that we saw as part of a defense in-depth strategy for cybersecurity. But as a leading vendor and an innovator in this space, we are also investing in providing packaged solutions that solve specific problems for the customers so that customers can get benefits for detecting certain type of stealthy or advanced threats or protecting a certain class of assets using deception technology. So we'll discuss some of the popular use cases that we have built for and that we can get value for our customers. So the first use case is identity. So in identity security, there has traditionally been the focus on prevention-based controls. So the prevention-based solutions are widely deployed, whether it's identity and access management, identity governance. And so things like, for example, multi-factor authentication, single sign-on, PAM, these are heavily deployed. These are necessary, but I think they are not sufficient in today's threat landscape because the adversaries are finding ways to bypass these. And so, for example, there are a lot of MFA bypass techniques that have been used by threat actors. There are also certain type of accounts, for example, service accounts that are not protected by MFA. And so adversaries use that type of single factor credential to go and bypass the prevention-based controls. So effectively, from identity security perspective, there is a new defense category called identity threat detection and response, or ITDR, which is effectively a detect layer which is focused on detecting identity threats. So there has been network detection and response, NDR, then endpoint detection and response, EDR, and now ITDR, which is detecting identity threats. So it's an exclusive layer focused on a threat detection view for identity. And so the whole objective is to detect threats that bypass the prevention-based controls. So this is a necessary component of identity protection. And from a deception tech perspective, there are traditional approaches to detecting identity threats. They can detect known threats with known attacker TTPs, like we discussed earlier in the discussion today, but they have several challenges and gaps. For example, offline attacks like curb roasting, client-side attacks, novel threats like 0 days. So there are many such techniques that are bypassing traditional forms of detection. And so a good example of that is the increase in curb roasting that we discussed earlier today. Deception tech is, as Chris mentioned earlier, is agnostic to the actual TTPs. And as a result, it can detect known and unknown zero threats, which are identity threats. So it becomes an essential ITDR layer to protect your identities. And in the case of identity security, you can create deceptive accounts that represent user accounts or service accounts, add them to your Active Directory or your cloud IAM repositories, create corresponding deceptive credential profiles and add them to the endpoints. These are known as honey tokens. And so the whole objective is to be able to detect identity threats early with precision and in a comprehensive manner. Anything that you would like to add on this, Chris?
I think this really underscores the challenge presented with identity protection. Like you said, a lot of the controls are focused on prevention, adding MFA, governance, centrally managing your identities. Those are great. But what happens if a threat actor using a native protocol, a native language to the environment, PowerShell or Python, creates a local identity on the system, creates a identity in your LDAP? Well, unless you have governance in place that's applying all the controls you already have, you're not going to be detecting that. So identity threat detection and response is it's a burgeoning field. It's, I don't want to say neglected by a lot of vendors. I know you guys are spending a lot of time working on this, but it's going to be a challenge for a lot of enterprises. And it's also, just coincidentally, not my topic, but it's a topic that we are working on researching here at GigaOM.
Thanks, Chris. Now we'll discuss another threat, which is ransomware. So ransomware has evolved significantly over the last several years. And now there is ransomware as a service operators, which is effectively a decentralized model where there's a separation of duties of the groups within the ransomware overall modus operandi, right? So there is the initial access broker whose responsibility is to get initial access for the human adversary into the target environment. So they provide access to a given organization. For example, you can specify as a ransomware offensive group, you can ask the initial access broker that I need access to a jump server for this enterprise, and that jump server should not have an EDR on it, right? So you can have that level of specification, and that type of access is then made available to the RAS affiliate. And so now the threat actor knows when they got the initial access that they are on a machine that does not have EDR, right? So they can pivot freely from that machine, download known offensive tools, and then go and conduct their campaign. So that's what the initial access broker does. Then there is the RAS operator who's building and maintaining tooling. So for example, we discussed ALFI and use of Rust. So there is a bunch of operators who actually build tooling using novel programming languages, using novel offensive techniques, and they provide the tooling to the actual affiliates. And these affiliates are now a distributed set of groups that actually have an ability to customize each ransomware variant and generate their own version of it. So you can have many different versions of ALFI, you can have many versions of Lockbit, and so each of them looks different and unique as far as the individual enterprise detection mechanisms are concerned. So it's become a very insidious and a stealthy threat, difficult to detect, and that's the level of sophistication on the offense. Now, from a deception perspective, deception is an excellent defense mechanism to detect ransomware, because what you can do with deception tech is, if you look at the overall ransomware offensive life cycle, the threat actor gets into an environment, might have initial access, and then typically they perform a few functions. They might try to evade defenses, they try to establish persistence on that target machine, typically look for credentials, then would like to laterally move because you want to compromise the entire enterprise instead of one endpoint, and then actually detonate the real ransomware. So if you set deceptions in the overall at scale, then deception can provide early detection to stop the ransomware. So you can detect the threat at the early pre-ransom stage. And because deception is agnostic to the TTPs, deception actually does not care whether it's Lockbit 2.0 or Lockbit 3.0, that is the campaign that is under threat. It actually is saying ultimately the threat actor will do the following things. They will look for credentials. The credentials will be privileged credentials. They're likely to be domain admins. And so if you can set up deceptions and traps based on the motives of the ransomware operator, then you will be able to detect irrespective of the particular campaign that is under operation in a given enterprise, right? So that's basically the idea. And because it's agnostic to the variant of the ransomware, you can get detection for current as well as evolving variants. So even if tomorrow's new ransomware variant, you can detect using deception tech by setting the right traps. Anything on this, Chris, that you would like to add?
No, I think it's important that we understand that RAS, the ransomware as a service, it takes everything that we hate about ransomware and it amplifies it. It makes it that much more of a headache.
Sure. We'll discuss OT and IoT security. So as Chris mentioned earlier, OT has been typically difficult to detect, to secure using traditional forms of security. Many of the assets in OT are not compatible with agent-based solutions. Like you cannot put, antivirus agent on a PLC or, for example, an HMI, right? So they're purpose-built equipment that is not compatible with adding additional agent-based tooling on it. And that's one challenge. The other challenge in OT is typically you cannot easily do vulnerability and those type of scans because the equipment is often brittle and it can get impacted. So which means that OT security has been a challenge. Traditional approaches of OT security have been focused only on air gapping, which is to try to say you actually isolate the OT environment and don't provide any access to IT. Now, air gapping is becoming less prevalent because OT does have some amount of increased interconnectivity with IT. For example, there is a common DMZ layer, there might be a common Active Directory, there is a network share, and OT equipment is also connected to the internet. And so there are many different pathways for the adversary to get into the OT environment. And so one needs effectively a detection approach. Deception is an excellent detection approach for OT because it, by definition, it does no harm, right? And it does not, at least in the Calvio's implementation, does not require any agents. So effectively, you're not disturbing your production assets. You don't create a scan. You don't need a span port, nothing. You're just creating a set of decoys and watching for activity against them. Chris, anything?
Yeah, you started to touch on it there at the very end. It's so important to understand. Anyone who's in the OT or IoT space, they already know this. For those who are not in that space, however, I think it's really important to understand that the CIA triad that we are all familiar with, the confidentiality, integrity, and the availability, those are our primary concerns as security professionals. It's really flipped on its head. It's not CIA and OT. It's AIC. It's availability first. Whatever you do not impact the availability of these systems. Secondly, let's make sure the integrity remains high. And then finally, for many of these systems, confidentiality is not a primary concern. So how does that play into deception? Deception is a very low or even zero impact to most environments that it's in because it's a wait and see. It's a bait and lure. It's the canary in the coal mine. The canary in that cage inside of the coal mine, that analogy, that example, that has zero impact on the coal mine. It's not like EDR, which may be a pneumatic drill in this example, going in and looking for things and scanning and breaking things apart. It's nothing like that. So I think that's a really important piece to understand when we talk about OT and IoT and how deception plays into it.
We'll discuss the role of deception in zero trust. So zero trust is effectively, as you know, a strategy and an approach. And so zero trust has multiple key principles, 3 key principles. One of the key principles is assume breach, where effectively, as part of a zero trust approach, the enterprise needs to assume that the adversary already has a foothold in the environment and then is going to propagate. And so if you assume a breach, then by definition, almost you need the ability to detect the adversary. So the detection layer is very much important. Organizations are at different levels of adoption and maturity in the rollout of zero trust. And there are different frameworks that have been set up, whether it's by DoD or by CISA, with the pillars which have been set up for zero trust, and then corresponding maturity level mappings to give you a pathway towards your zero trust journey. But ultimately, detection is a very important goal. And from a detection goal perspective, the threats that bypass the current levels of defense are not getting detected. And as a result, if you do not have deception, then typically your zero trust implementation would not reach the right level of maturity. And so one needs improved visibility and analytics And in the DoD pillars model, there is a dedicated pillar for visibility and analytics. In the CISA 5-pillar model, that's known as a cross-cutting capability that cuts across the 5 pillars, and so which is all focused around providing visibility to threats. And so deception tech maps to the visibility and analytics pillar or the cross-cutting capability, depending on the model, and it protects all the assets across the other pillars, whether it be network, identities, endpoints or devices, data, and applications. And so you can create deceptions of different types and detect threats against any of these types. Effectively, the organizations can enhance their threat visibility, eliminate the detection blind spots using deception tech, and as a result, to mature your zero trust implementation and strategy, organizations should consider the application of deception-based threat detection as a necessary control. Q&A.
All right, so let's get started. We still have a few minutes for Q&A, and there are a few questions. Let me start with the first one. How is the threat early detected?
Yeah. Would you like to say anything, Chris, on that?
Yeah. The best way to explain this is to either pull up the MITRE ATT&CK framework as I walk through it, or just picture it in your head. As you know, there are 13, 14 categories of TPPs. Most detection methods today begin to become really effective somewhere in the middle or to the right. So middle to the right is in the middle or in the very late stages of an attack. I'm talking about the credentialed access, the discovery TTPs, even lateral movement. That's pretty late in the stage. Lateral movement, I believe, is the 11th category. Starting all the way over on reconnaissance is number 1. Deception is moving the detection further to the left. It could happen as early in the reconnaissance, as early in the attack cycle as reconnaissance. It's more likely you're going to find it during the initial access, but that's way better than the 11th stage. When you consider that is the 3rd stage. Hopefully that helps.
Sure, thanks, Chris. Question, I have tried deception manually. Why do I need a platform?
Chris?
Sure. So again, getting back to the business criteria that I talked about, my favorite one, the one I weight most heavily, that's ease of use. If you've done any deception technology deployments manually in any significant size environment, I'm going to say more than 15 to 20 users or endpoints, the amount of overhead required to deploy initially and then maintain the deception to either the endpoints, to the users, to your infrastructure can quickly become a full-time job, even at a smaller organization like that. You can imagine scaling hundreds of endpoints, thousands of endpoints, tens of thousands of endpoints, or a global presence. You would need a team and you would need an army of people to manually do what a platform can do for you.
Thanks, Chris. I think the next question is for you as well. When implementing deception operations, where have you seen it fall within an organization? Who takes ownership of it? Does it become a new department or a part of existing one? Or what do you recommend?
This is going to be very widely depending on the type of organization, the size of the organization, and the maturity of the organization. So it's hard to give a really good one-off answer for this. I can give you some generalities though. A startup, it's going to start with the security team. It's going to maintain with the security team, and then the security team is going to have to advocate for keeping it. So tracking metrics, you're going to need a platform that gives you good reports and alerts and helps you prove its value. If we shift now to a large enterprise, that's going to look much more like your typical acquisition for cybersecurity tool. It's going to go through its acquisition process, but it will have a champion somewhere, probably in the security operations, and it will remain with the security operations. Hopefully that helps kind of fill in some of the blanks.
Sure. Thanks, Chris. Yeah, questions are coming in. How is it integrated to SIEM and SOAR what is the best practice? Do you recommend using alone or to be integrated? Maybe, Cyril, yeah, go ahead.
I'll take a stab at the second part. The first part is going to vary depending on the vendor, so I'll let Cyril fill in, their part here. But simple answer, yes. You should always send everything you have to your scene. This is no exception to that.
Yes, and from a Calvio's perspective, absolutely, I completely agree with Chris. The SOC needs a single pane of glass. Ultimately, deception is one of the detection layers. And so as part of defense in depth, you have multiple layers of detection, but all the detection signals need to be aggregated at a central repository, which is typically the SIM, could even be the SOAR in certain cases directly. And from a Calvio's perspective, what we have done is SOC teams need a standardized taxonomy to drive the incident response workflows. And so we classify all the deception observations to the MITRE attack framework. And so we have a built-in AI-based threat analytics engine that takes the adversarial actions in real time, classifies it to the corresponding tactics and techniques in the MITRE attack framework, and then sends it to the SIM or the SOAR. That way, the SOC team has a standard point of reference for their incident response. Go ahead.
Sure. Chris, I think a question for you again. Given how highly ease of use is rated, I'm curious how Chris and GigaOM rank this.
Sure. So this is getting further into the weeds. Business criteria, the evaluation methods can be abstract, but we try to make them as objective as possible. So when we're talking about easy use, what we're looking at are there quality of life features in this solution that you expect to find in a modern piece of technology, such as simplified menus? How much of the work needs to be done on the command line? How much of this work is done behind the scenes through automations, through artificial intelligence like machine learning? Some vendors are now integrating things like an LLM, a large language model, that provides sort of a easier to interact with method to glean and extract the expert information out of the system. But we're also going to look at how does the vendor support it? Is there a full support contract included? Is professional services included to help you integrate it into your environment? Do you have a dedicated technical account manager if you're of size? So it's a very comprehensive look at ease of use. It's not just considering the technical features within the software itself.
Thanks, Chris. Okay, we have another couple of minutes and there are many questions. So if we don't get to your questions, we'll make sure that we respond to that via email. The next one is, how can we use deception tech at the network layer, L3 to L7 layer in specific?
I'll let Cyril, yeah, go ahead. I'll let you jump in on this one first.
Yeah, so deceptions are a great way to detect network threats. You can have deceptions at many different layers of the OSI model. So for example, you can set up decoys to detect, you can open a low interaction decoy to just look at a TCP connection. So for example, a layer 4 connection, but you can go all the way till layer 7 where you actually have an application decoy that serves up, let's say, a web server or a database server, which actually interacts with a particular type of, which provides a response to the type of interaction to the adversary and talks to application protocol. Go ahead, Chris.
Yeah, that's pretty much it. The really crude example I gave is you may deploy a honeypot, just a vulnerable system, and it may run a specific vulnerable version of OpenSSH. That's very simple. You could also move it up. You could have it run a specific version of a web host that you know is vulnerable. Even better, you could run a specific version of a web host that has specific types of vulnerabilities, where then you could bury a bait or a lure if that vulnerability is executed on that host. So you can layer in deception that starts at the network layer, which is very common. Pen testing, red teaming, real attackers start in the network layer and work their way up to completely compromise the system. You can layer in deception that way to make the detection higher fidelity and higher value.
All right, 1 more minute left. Let's take one more question or maybe two, depending on. So what happens if a real user access access the honeypot regarding the reputation of the company. So it looks like more around internet-facing honeypots. But Cyril, do you want to comment on that?
What happens if a real user accesses a honeypot? Is that the question? So if a real user accesses a honeypot, effectively one would call it like it's effectively in the case of Acalvio. Typically, if there is like somebody just innocent probe for a decoy, then the probe is what is called as a discovery, where it's just like a touch to the decoy. And so we actually classify discovery probes differently from probes that are actually offensive in nature, where the adversary has attempted credentials, has attempted vulnerability exploits. And so anything that could be innocuous is surfaced as a discovery type of probe, and it is classified independently. That way the SOC team can decide to potentially ignore that as part of their incident response.
Yeah, I think I'll add there like a question just by reading it. It looks like that the person is asking mostly internet facing, like from outside, outside the network kind of honeypots. Not so we typically kind of focus on something inside the network, and yes, for outside as so yeah. I mean,
for the outside case, there is effectively most likely there'll be a lot of there can be a real user, but there can be a lot of scans that would have been detected by internet facing before, right? And so the whole the trick in the case of internet facing deception is to make sure that you focus on generating threat intel instead of trying to just raise an alert on every scan, because you don't want to overwhelm the SOC. So instead, where internet facing deception is useful is to say, did I see a log4j being attempted? So did I see a new type of a vulnerability exploits? You capture the threat intel. For example, a password spraying is being attempted, or a log4j is being attempted. You capture the adversarial intelligence and surface that as new threat intel to augment your current threat intel. That's basically a good use case of internet-facing deception.
Chris, do you have anything to add there?
Nope, that's pretty much what I was going to say. Is you'll see deception used on the internet primarily for threat intelligence gathering, very infrequently for detection and alerting.
There are many questions that some of them are about best practices and things like that. We'll respond to that via email, or maybe point you to a blog or two. But we are already 2 minutes over. Respecting your time, I would like to close the webinar. Thanks, Chris, for the radar report and coming to the webinar and talking about it and answering the question. Thanks, Cyril. Recording of the webinar will be sent to everyone who attended and registered, and we'll follow up with some of the unanswered questions. Thank you so much. Bye-bye now.
Thanks, gentlemen. Bye.